Hello, everyone. My name is Ravindra Gautam, and today I will be presenting my research on AI driven architecture as a service, or I call it triple AAS or AQS for financial systems. This research I have done explores how artificial intelligence can transform the way we design um, our financial software infrastructure solutions and systems. So let's dive in without any further ado. So next slide is introduction and background. So I want to tell you, uh, I work for an investment bank here, and I've been in this industry for a couple of years, and I'm seeing a lot of changes every week, every day, every month, and for the last couple of decades, financial sector has accumulated a lot of technical debt. So now I think many big financial companies they are, trying to get rid of legacy technical debt, and they are moving to public cloud. They are, modernizing their security, and they are making a lot of process changes, automating things. So basically the financial sector is going through a rapid digital transformation with real-time processing needs, regulatory constraints, and there is a big demand of 24 by 7 availability uh, from the clients. So having said that, traditional software architecture approaches are no longer sufficient, and what we need is a flexible, scalable, and intelligent solution to design our financial systems, and that's where this architecture as a service, especially AI-driven architecture as a service, comes into play. It allows for real-time adaptation, compliance enforcement, and self-healing architectures um, based on a lot of things that the changing world, threat vectors, and multi-cloud situation, hybrid situation. So lot of factors it can learn from, and help you with uh, you know designing intelligent financial systems. Now moving on, uh, before we go further, I would like to clarify some of the key terms I am using in my research. So this AAAS or AQS is architecture as a service, essentially delivering architecture design and governance as a service. And the second one, regulation as code, it refers to encoding, compliance policies or NFRs, so systems can enforce them programmatically. We talk a lot about infrastructure as code, policy as code, so I'm using here regulation as code. Self-healing architecture means systems can detect and fix fault automatically in the architecture. It can detect, it can notify, and it can provide you suggestions. Uh, and architects basically will use this tool, and they will be able to get a lot of benefit by looking at things and in perspective, and with a lot of inputs behind the scene being used for making decisions or choices. And the fourth one is multi-cloud orchestration. It means managing deployments across different cloud providers seamlessly. And the last one is compliance engines. So I think engines will keep an eye on changing compliance world, right? Regulatory changes and other things. So it will keep on processing and keep the rule engine updated. Now, next one, financial firms basically today, um, they are, they have or face several pain points. And I've been working in this industry for a couple of years, so I witness these pain points every day. So the number one is aging legacy systems, and financial companies, they cannot, keep up with you know time to market and new features for the clients, because legacy systems, they have a lot of limitations. So, and the increasing cyber threats, global compliance mandates, there are a lot of things. Now customer expectations for are there for always be beyond service, right? So these challenges push the limits of traditional architectures, and architecture as a service solution provides a dynamic solution, allowing systems to, adapt in real time and ensure compliance and reduce human intervention in the architecture phase, design phase, basically. So it can really help um, software architects or solution architects or enterprise architects or even security architects. Next one, so the objective here. So my research focuses on four main objectives. The first one is uh, to explore how AI can automate architectural decision making. And the second is uh, we need to understand the obstacles to implement architecture as a service in hybrid and legacy environments, and even multi-cloud environments. Third is to evaluate current tools in use today. And finally, uh, the proposal or a conceptual framework for a future-proof AI-driven architecture as a service system tailored for financial services. Uh, Now, the next one is, so my research questions. I tried to answer these four main questions. The study I've done is guided by you know these four main questions. If I were to say, how can AI automate design for scalability and compliance? What are the limitations of current tools? And the third one is, what architecture models support resilient, self-healing architectures? And finally, what research and standardization are needed to make AI-driven AAAS viable for the financial sector? Now, moving on. Okay, so methodology overview. So to answer these questions, I used a mixed method approach. I combined literature review, case studies, and analytical frameworks. And this allowed me to study not just the theoretical advancements, but it also helped me with real world implementations of automated architecture in the financial industry, or automated frameworks um, in in the financial sector. Now moving on. So, systematic literature review here. I reviewed over, I think, 40 plus sources from IEEE, ACM papers, white papers from major cloud providers, and regulatory standards like NIST and CIS. I also focused on materials from 2018 to 2024. I just wanted to make certain that it has latest relevance, basically. And the goal was to understand how AI compliance, NFRs, and cloud orchestrations intersect in modern architectures and even like SaaS. There is a lot of there is a fashion now to go to SaaS and not worry about any infrastructure or even platform or anything. Just use the service as you go. So all those things I basically focused on. Now, so case studies here. I picked up these tools you're seeing on my screen. So I looked at like majorly 5 real world tools and platforms: IBM Cloud Pak, AWS Financial Services Lens, Azure Blueprints, Google Anthos, and AI DevOps models in fintech. These tools basically helped me ground the findings in practical, applicable technologies, and also exposed gaps in current capabilities these tools offer. Uh, Moving on. So my analytical techniques, I would like to talk about. I built taxonomies and comparison matrices to categorize tools by their capabilities like compliance enforcement, scalability, and self-healing nature. I also validated findings against key regulations like GDPR, PCI DSS, NIST, and CIS to ensure actually they meet financial sector standards, because I'm quite familiar with these frameworks, regulatory frameworks, because I work as a enterprise security architect for this investment bank, and I deal with security you know every day. So now, core challenges I want to talk about. There are 4 big challenges. One is jurisdictional compliance, like regional enforcement of regulations. Data laws, they differ across countries. If you go to India, you go to Luxembourg, you go to any other countries in UK um, and US, and so there are different data laws basically. Two is legacy integration. Many core systems are decades old, as I said in the beginning. uh, for last couple of decades, I think financial sector or financial companies, they have you know piled up a lot of technical debt, so legacy systems are decades old. Third is the lack of financial grade patterns in existing tools. And uh, finally, the last one is orchestration across multiple clouds. It remains difficult and error prone. Now, moving on. So, what are the limitations in current tools? Current tools basically they fall short in 4 areas, which I've listed here. They don't fully integrate AI, because these tools are old, and AI is the latest buzzword, or latest like not latest, but very very new technology. Last couple of years it got a lot of popularity, and these tools cannot enforce compliance in real time, based on the changing attack vector, or regulatory changes. They are very much templatized and static in nature, and these tools are weak at orchestrating across clouds and even hybrid scenarios, and often they require manual enforcement of policies. So these limitations make them um, suboptimal, I would say, for financial use cases. Now, what are the opportunities with AI? AI can bridge these gaps basically. So, with machine learning, we can create predictive designs and detect anomalies in real time. If you are integrating two systems together based on the connection or the protocol you're using, AI can help you detect the anomalies there and provide you multiple choices, and based on the security rating or other this there are a lot of other things we use, like cap theorem and CIA triad and all those things, right? And we can also use blockchain, and it can ensure, because blockchain is immutable, so it can ensure immutable audits. And AI driven orchestration can I think optimize workload placements across clouds and based on legal, performance, or cost considerations. Next one. All right, proposed architecture components. So I have drawn an architecture. It's on the next slide, but these are the major components I have considered. So my proposed AI-driven architecture is a service architecture. It includes um, an AI engine for intelligent decisions, a design optimizer for creating blueprints, a compliance engine for regulation enforcement, a deployment orchestrator for execution, a health monitor for runtime integrity, and a feedback loop to refine decisions, using real-time data and changing data. Now, this is the architecture you see. So this is, I think, same what I explained on the previous slide. These are the components and how they will be tangled or integrated together. And this is very high level, like 30,000, 40,000 feet overview. But I think this is how we can layer this architecture as a service tool. Now, moving on. And if I go back here, no. So just to add here, and the diagram is kind of illustrating the proposed architecture. I haven't done the implementation. So the center stage is taken by the AI engine here, and all these components, they will work together as I explained. Now, uh, strategic roadmap here. So if we want to operationalize this vision, I think we need to develop domain-specific AI models, financial domain-specific AI models. So it's a lot of work there. Standardize architecture as a service frameworks with the regulators, because I think we need to make certain that decisions are reliable and they meet regulators uh, you know demand or requirements. Then we can modernize legacy systems using APIs, and embed policy as code there, and adopt centralized orchestration for multi-cloud governance. Now, this is my gap analysis table. This table basically compares existing tools, which we already talked about on one of the previous slides, and it is comparing these tools with the proposed architecture as a service framework or tool. So as you can see here, existing tools only partially support regulation as code or legacy systems, and more offer AI-based healing. This architecture as a service offers more AI-based healing. Uh, Basically, this table overall highlighting the need for a dedicated intelligent architecture as a service platform to help solution architects, enterprise architects, security architects, and system architects, infrastructure architects, so that they can design intelligent systems. Now, next one is taxonomy of architecture as a service capabilities. So here I'm categorizing architecture as a service capabilities into four core areas: compliance enforcement, scalability, resilience, and observability. These can help us map current tool capabilities and guide future development. Now, the next one is future research direction. So again, there are certain things left over here. This research paper doesn't cover everything, so I'm highlighting what are the future research directions. So I think key research areas can include building autonomous learning systems, creating blockchain-based audit networks, translating legal texts into policy automatically with full automation, and standardizing architecture evaluations with the processes across regulatory bodies. Now, next one. So here's the summary of key contributions. So this research provides, as you have, I think, by now, understood, AI-driven architecture as a service platform, and it is basically tailored for financial services, and it identifies critical, tool gaps, and also offers a roadmap to move forward. Um, so I would say it contributes to both academic understanding and practical implementation. But as I said, I haven't done any practical implementation. It is the idea and the high level solutioning and architecture of architecture as a service platform. Uh, so there are some limitations of my study here. Uh, if I were to, categorize these few limitations, so the framework is conceptual and not yet implemented, as I already highlighted. And public data on financial architectures is limited because these companies they do not make their architectures or solutions um, available publicly because it's sensitive information uh, to those companies. And existing tools may evolve rapidly, but potentially, I think, closing some of the uh, current gaps. Now, if I were to conclude this, here are some bullet points, but I will summarize this for better understanding. So AI-driven architecture as a service can be a game changer, in my humble opinion, for financial architectures. Um, with this ability to automate, adapt, and enforce compliance, NFRs, it's a powerful model, I would say. Um, However, collaboration between technologies, no, not technologies, technologists and regulators is essential to realize its full potential. Um, Now, so I have included a couple of references here. As I said, I have gone through 40 plus sources, so but I couldn't accommodate all of them here. But I have included nine main, references from my list. Now, I would like to thank the University of North Dakota, Dr. Hassan Reza, and all my mentors who helped me, you know, with this research. I also want to acknowledge the use of AI tools like, Quill bot. I think there is a website which I use for, some grammatical, corrections, and also some idea generations and content structuring during preparation of this research paper. I would like to thank you all for uh, going through this presentation and for your time and attention. I hope this presentation provided a meaningful perspective on AI driven architecture as a service in the financial sector. If you have any questions, please feel free to reach out to me at ravindra.gautam@und.edu. Thank you so much. Uh, okay.